Alright, this is a review of what we've learned so far in our unit about discrete variables and binomial distribution. A lot of big words going on. This is our Unit 6, Part 2. Make sure you can do every problem on this review by yourself without the video. Problem number 1. If you choose a student at random, what is the probability that she will have a C? Now a C is a 2 by this scale. In fact, let me just go through. So this is A, B, C, D, and F on a 4-point scale. So the probability that she will have a C, that's the probability that X is equal to 2, and that is 0.31. If you choose a student at random, what's the probability that she will have higher than a D? Well, higher than a D would mean she would have a C, a B, or an A. So we're just going to take the sum of those three probabilities. This is how you need to show your work. First of all, you must show your symbolism, sort of like I did right here when I said the probability that X equals 2. I need to write the probability that X is greater than 1. Okay, this part is not optional. You must show your symbols. And then just show what you're doing. So we're doing 0.31 plus 0.28 plus 0.26. So that's 0.85. Alright, one of the main reasons why you need to show your work as far as this part right here is if you do make a mistake and end up with the wrong answer, if you showed your work, I can give you partial credit. If you just have an answer and your answer is even slightly wrong, I just have to take off all the points. So it's in your best interest to show as many steps as possible to show your very good thought processes, and I can give you points for your good thought processes even if you made some tiny error along the way that caused your final answer to be wrong. So show lots of steps like this. Alright, number 3. Spell check software catches non-word errors which result in a string of letters that is not a word, as when THE is typed as TEH. When undergraduates are asked to write a 250-word essay without spell checking, the number X of non-word errors has the following distribution. Brat, there it is. First of all, let's fill in the probability that X is 3 to make this a legitimate probability distribution. Well, the probability that X is 3 is this empty one right here. If it's legitimate, all the probabilities should add up to 1, meaning 100%. Okay, so the easiest thing to do is to start with 1 and subtract all the rest of these probabilities. So I'm doing 1 minus 0.1 minus 0.24 minus 0.32 minus 0.11. That's what I'm doing. So I got 0.23. Now draw a histogram for this distribution below. What is the shape of the distribution? Alright, so a histogram is similar to a bar graph, but there won't be any spaces between the bars that we're going to draw. You have to decide what the scale is going to be. So you want to scan over and look and see what's your highest value, and then think about how you want to use your scale so that you want your histogram to fill up the graph as much as possible without shooting through the top. So I see that 0.32 is my highest value, so I'm going to give it some thought. I decided it would be great if I could count by 5s. So I'm going to go 0.05, 0.10, 0.15, 0.20, 0.25, and 0.30. This will give me a nice spread, and even though my 0.32 is going to go just a little bit above this, that's fine. Now, as far as the x-axis here, I'm just going to use my x values, which are 0 through 4. Okay, so I'm just going to go 0, 1, 2, 3, 4. So the 0 is at 0.1. Okay, so that's right here, 0.1. Okay, so, alright, this is really hard to do. My 1 is at 0.24. Okay, so 0.25 is right there, so it's going to be just barely below that. Okay, wow. Alright, let's just pretend that didn't happen. And then my next one is at 0.32, which is just over the top a bit. Okay, this is harder than it looks. Okay, guys, there's friction on this pad, and it makes it jumpy. So don't judge, is my point. And then we have the 0.23, okay, which is going to be just a little bit closer to the 0.25 than the 0.20. And then the last one is 0.11, so that'll be just a bit above the 10. Okay, there is my histogram. We're supposed to describe the shape, and the choices are: is it skewed left, skewed right, is it symmetric, or is it bimodal? This seems very symmetric. It doesn't have a clear tail in either direction. It's got a lot of balance, so this is symmetric. Okay, I think that was it for that. Let me zoom back out. In fact, let me tighten this up. Okay, moving on. Now, according to an article appearing in the Wall Street Journal, about 65% of U.S. households have a landline phone as opposed to a cell phone. Suppose you select 9 households at random. So we need to explain why this follows the binomial setting. Well, the binomial setting, there are 4 conditions that have to be met if it's going to be the binomial setting, and then there's that special formula that we can use if it fits the 4 conditions. I like to use the acronym SPIN to help me remember the 4 conditions. Alright, I used to call this SNP, but then one of my students said, can we use SPIN if we want? And I was like, you know what, SPIN is better than SNP. SPIN wins. So SPIN it is. The S of SPIN stands for success or failure. Alright, you have to be able to break down your variable in terms of being either success or a failure. Just 2 choices. So in this case, we're talking about the percentage of households that have a landline. So if you select 9 households at random, either they have a landline or they don't. So that's your success or failure. Alright, landline or not. Okay, the P in SPIN stands for probability. All of the outcomes have to have the same probability of success. Ugh, man, I'm not thinking straight today. Same probability for all outcomes. In this case, there is a probability that's given for all the households, which is 65%, or p equals 0.65. Alright, for the p in spin, you should, whatever else you say, you should end by saying what the p equals. Alright, I stands for independent. Alright, this is a little bit more difficult to be specific about. But you're going to want to say that each outcome is independent. Okay, and in other words, whether or not the Smiths have a landline has nothing to do with whether or not the Joneses have a landline. Alright, I reworded it a little bit so that would all fit. I was running out of space. So, independent outcomes. One household having a landline has no effect on another household. Alright, so they're independent. And finally, the N of spin stands for there's a set number of outcomes. In this case, n equals 9. Okay? For the p and the n, always state what the p and the n are. P equals 0.65, n equals 9. Alright, those two, you have to say that. Alright, so just make sure you mention all four of your things. S stands for success or failure, P stands for same probability, I stands for independent outcomes, and N stands for set number of outcomes. So S, P, I, N. Alright, just in case you weren't getting it, now it's in your face. Now, define the random variable x. Okay, it's the number of. So basically, back when we said success or failure, x is going to be the thing that we decided was going to be a success. So success or failure, you either have a landline or you don't. Okay, so success is going to be the number of households with a landline. Alright, so let's move on to part C. Notice, even though this is flipping to the back of the page, this is still all part of problem number 4. So these numbers. In fact, alright, we have decided that this is the binomial setting. So in short, once you know that you've got yourself the binomial setting, then we abbreviate it this way. B, and then we put our N and our P. Okay? So in fact, let me write above this. So it's B, N, comma, P. The set number of outcomes and the set probability. So what we have here is 9, comma, 0.65. Okay, this is what we have. So now, armed with that, I can do the rest of the problem. Okay, so give the probability distribution and the cumulative probability distribution of x. Show your setup. Now, at this point, you have two choices. You can either use your list features of your TI-30 XS multiview to just find all the probabilities at once. Or you can calculate one probability at a time if you don't know how to work your calculator efficiently. Before we get into that decision, we will start by listing our x values. Remember, x is the number of households that have a landline. So it's possible that out of our sample of 9, maybe none of them have a landline. Right? Maybe we have a cell phone only group. But on the other end of the spectrum, maybe all 9 families have a landline. So, and we have everything in between. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's a total of 10 possible outcomes. So, write that down. Now, what I'm going to do is I'm going to calculate one of these probabilities by hand. So the students that wish to calculate these probabilities one by one, you can just copy that process over and over again to get them all. And for the students that want to use your calculator to auto-calculate all the probabilities, we will use the 1 to show us how to build the formula to put in our calculator. Okay, so let's find the probability that exactly 4 households have a landline. Alright, we'll use that as our one case I'm going to work out by hand. Alright, there's a formula to it. I'm going to zoom in a bit so I can just do it properly. Okay, now, so here's the formula to it. We're going to have 3, alright, so this is what I'm doing. I'm doing the probability that x equals 4 right now, just that one. There's going to be 3 parentheses that you're going to see me do. Alright, this is just a way of helping you remember what to do. 1, 2, 3 parentheses every time. In the first parentheses, we're going to do a combination. Okay, something choose something, the way I say it. Okay, and the first number has got to be the total. Okay, it's always going to be this n value that we had up front, the total number of outcomes, which is 9. Okay, so first in my parentheses, I'm going to put 9. All right, that's always the total. I didn't like that 9, so I'm going to do that over again. I said 9. Better. All right, and that's going to be 9 choose. And then you're going to put the number of outcomes that you are interested in. So we want the probability that 4 households will have a landline. So out of a total of 9, we're talking about 4 successes. So that goes here. So that's it for your first parentheses. In your second parentheses, you're going to have a probability. In fact, the remaining parentheses are both probabilities. This first one will be the probability of success, and the second one will be the probability of failure. The probability of success is the thing that we wrote down at the beginning, 0.65. It's that 65% that they gave us on the previous page, 65%, 0.65, all day. So we're going to put 0.65 right here as our probability of success. Now let's go ahead and write down our probability of failure. Okay, in my mind, I think about the fact that the probability of either success or failure, that's got to be 100%. Okay, either you're going to succeed or fail. That's 100% probability. So these two together have to be 100%. So I could either think of it as 100 minus 65, or I can think of it as 1 minus 0.65. Same thing. Alright, either way, okay, so if I do 1 minus 0.65, for example, that gives me the other probability. Hold on, you can't see it real well. Alright, that gives me the other probability of 0.35, 35%. Okay, so this is the probability of failure, is 0.35. Okay. Alright, so in general, there's a 65% chance of success and a 35% chance of failure for a total of 100%. Okay, now, both of these probabilities get an exponent. Alright, the probability of success, and then we need to put the number of successes. Well, that's the 4. Alright, we want the probability of 4 successes, 4 houses with a landline. So this gets a power of 4. By the way, these two numbers will always be the same, because this is the number of successes, and this is also the number of successes, so just duplicate. Now, we have the number of successes. Alright, now the probability of failure is going to get the number of failures. Okay, on the number of failures, look, the total is 9. So if we have 4 successes, how many failures must there be? There must be 5. Alright, these two have to add up to 9. It might be helpful to think about it as the total minus the amount that we had so far. So 9 minus 4 is 5. You're always going to be subtracting these, but you know, they always add up to the total, of course. Okay, so that's how you do it. And then you just put that in your calculator, and that gives you the answer. Alright, so we're going to do our 9 choose 4. So open parentheses, 9. We'll do the probability button. Combination is item number 2. 9 choose 4, close parentheses. Now, for the probability of success, so that's 0.65, close parentheses, to the power, alright, the number of successes, 4. Now we'll do open parentheses, probability of failure, 0.35, close parentheses, and we decided that the power would be the number of failures, had to be a total of 9, so 5. Hit enter, and there you go. So 0.1181, 4 decimal places, please. Round if necessary. If this had been a 6 instead of a 3, then I would have rounded this up to a 2. 0.1181. Okay, so 0.1181. So that is the probability that exactly 4 families will have a landline. Okay? So you could repeat that process over and over again for 0 families, 1 family, 2 families, 3 families. Okay? Like for example, if you wanted to do the probability that 3 families had a landline, okay, you would just change these 3 numbers. So it'd be 9 choose 3, and this would be the third power, and this would be 6, okay, because 9 minus 3 is 6. These two have to add up to 9. And you would just put that in your calculator, and you could just do that over and over again. Okay, now let's see how to put this in the calculator. Of course, I'd have to change that too. So the probability that x is 3 is what I'm showing here. Alright, now if you're going to do it that way, then you have to show this work 10 times. Alright, so I should see these little calculations, like 10 of them down below. Now, or you could put them up here. But up here, I'm going to put the calculator version of this. Alright, so the probability of x, okay, is going to be, in fact, I should say the probability that x is equal to list 1. Because, look, what we're going to do is we're going to put all these x values in a calculator list. So hit the data button on your calculator. Just reset your calculator. So I'm going to reset. Okay, you hit the data button on your calculator. You're looking at 3 lists. List 1, list 2, and list 3. Our x values are 0 through 9. So just type in 0, enter. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, now list 2 is where all the magic happens. Alright, this is where we are going to use a formula to automatically generate all of the probabilities. Now, let's use our work that we did when we did one problem by hand to figure out the formula that we will put in the calculator. So looking at this right here, what you want to do is, so look at everything in blue stays the same. So that's definitely going to be part of it. So I will have 9, choose something, and then I'll have my 0.65, then I've got some kind of a power, and then I've got my 0.35. All that stuff in blue, regardless of which number of successes we wanted to look at, the 3 or the 4 or the 5, everything in blue stays the same. So the stuff in pink here, this is where we need some sort of a calculator style variable. Now remember, this 3, which started out as a 4, is an x value. So these are the x values, and the x values are sitting here in list 1. So everywhere you see an x value, we need to have list 1 as a variable. Okay, because that will give us whichever x value we want. And that's the same thing here. This x value and this x value are always the same because that's the number of successes. And so we need to put L1 as the power as well because these are always the same. Now the last one is this other exponent. Now the other exponent came from doing the total minus the number of successes. Alright, 9 minus 3 gave us 6. Okay, so it's always going to be the total minus the x value. So we're going to have to do 9 minus L1 because that's where our x values are. This one's going to have to be in parentheses because it is a difference. You need to put it in parentheses. So 9 minus L1. So that's it. This is your calculator setup. If you're going to do calculator style, you only have to show it once. Okay, and this is what's going to go in your calculator. So how do we put this in our calculator? Where do we put it in the calculator? Well, let's check it out. This is a formula that we want. So hit data. Make sure that you are in the make sure you're in list 2. So arrow your way over to list 2 because this is where we want the formula to be. So hit data, change to the formula menu, okay, and we want to add a formula. So just hit enter. Okay, so look here. Alright, this is where we are adding in our formula. Now we're just going to type in this, the formula that we just decided on. So we'll do open parentheses, and then we decided we would do 9, choose, and we need L1. So the way we get L1 is you hit the data button, and then there's L1, so just choose it. So that's 9, choose L1, close parentheses. Now the probability of success, so 0.65, close parentheses. Alright, now we're supposed to do to the L1 power. So we will do caret, and then again with the L1. So we'll hit data and choose L1. Okay, so that's 0.65 to the L1 power. Now the last parentheses. Now we need our 0.35, our probability of failure, and be very careful because I mentioned to you that this needs to be in parentheses. So 9 minus L1, the total minus list 1. So parentheses please, 9 minus, alright, back to data one more time, list 1, close parentheses. If the most common mistake here is students will forget to put this last exponent in parentheses, and you will get the wrong answers. So if I go ahead and hit enter now, then it gives me all of the probabilities. Okay, and I just need to copy them down. Notice, alright, it's a little bit strange here. the first one. It's a good one to talk about it. See how this first one is 7.9 e negative 5. Okay. Now, please do not copy down 7.9 e negative 5. Do not put that on your table. All right, you will lose points for that. But instead, understand that this is scientific notation. This means 7.9 times 10 to the negative 5th power. Your calculator is doing this because the decimals are not fitting in the small space. However, not to worry, if you look down at the bottom, you can see that it's giving you the details out the long way. So what we have is 0.00007. Now, if I want 4 decimal places, okay, that's 0.0000, I just need to know, do I leave it at 0 here, or do I round this up to a 1? And because this is bigger than 5, then I'm going to round this up. So this will be 0.0001. And that is what you write down. 0.0001. And so on. 0.0013, etc. Alright, I'm going to pause and write down the rest of them. As I'm copying them down, I will jump in and mention. So this one, remember the 4 is the one that we had calculated by hand without the table feature. So it's useful to make sure and see, are we getting the same answer by this list method? So let's see. So as I scroll down to item number 4, and I see 0.1181, and that is what we came up with when we did it by hand. So it confirms that it's working as promised. And I'll just write down the rest. And there you go. Okay, so that is our probability distribution. Now, the cumulative probability distribution is very simple. You're just going to add up the numbers as you go. So the first one is always just going to be the same as the regular probability, so 0.001. The next one is going to be the sum of both of these. So it's going to be the sum of the one where you are. So basically, each one, like here I am at an x value of 1. So I'm going to do x equals less than or equal to 1. That's what I'm really doing here. Okay, so I'm adding up all of these. Okay, so I can do that in my head because that's 13, 14. So that's going to be 0.0014. Alright, now for this one, I need to find the sum of all 3 of these. That's what I'm doing now. Now, I already know that 0.0014 is the sum of these two. So all I really need to do is add these two. Okay, so I can just do 0.0014 plus 0.0098. So that is 0.0112. Okay, next I need to add up all of these. Okay, for this one I need to add up all of these. So again, I can pick up where I left off and just add 0.0112 plus 0.0424. Okay, so I have 0.0536. Okay, and then you just repeat that process over and over again. But just understand that each time you don't have to start over from scratch. Okay, if now I want to add from here, I will just take the previous sum plus the new one. So I just need to add 0.1181. So I already have this number in my calculator, so I can just put plus 0.1181. And that gives me the new total, 0.1717. Alright, and just do that over and over again until you get to the end. Alright, notice as these numbers got bigger and bigger, 0.39, 0.66, 0.87, 0.97. In the end, they should all add up to 1, because by the time you get to the end, what you have just found is the sum of all the numbers. Alright, this last one is the sum of all the probabilities. And we know that if this is a legitimate probability distribution, if you add up all the probabilities, it better equal 1. Now, sometimes you do some rounding. So if you get 0.9999, that's okay. Alright, so that's all there is to a cumulative probability distribution. Now, as far as the shape of a cumulative probability distribution, just imagine it. You really don't have to draw it. But just understand this. Our probability distribution was just getting bigger and bigger, right? Hold on. So if you did do some kind of a histogram, it would have looked like this. You started off with some small probability, and then because each time you're just adding, alright, so it's getting bigger and bigger and bigger every time you go along. Alright, all you're doing for the cumulative is adding and adding and just adding on the next one and the next one. So all cumulative probability distributions are going to have this general shape to them, where in the end, this last bar is going to have a value of 1. Okay, so how would you describe the shape of this type of a graph? Would you say this is skewed left, skewed right, or symmetric or bimodal? Alright, hopefully you have learned that this would be considered skewed left. Okay, because if you look at the tail, look at the small end, whichever way the tail goes, that's the direction in which it is skewed. So this is skewed left. And all cumulative probability distributions will be skewed left. Okay. Find the probability that at least 5 of the 9 households have a landline. At least 5. Alright, again, you must put the symbolism. At least 5 means x is greater than or equal to 5. So you have to write this down. Alright, probability of at least 5. So that's greater than or equal to 5. So that means we're adding up these numbers. Okay, right here. Alright, and you should write that down. Alright, yeah, that's right. I cheated and cut and pasted. But this is how you show your work. You just take those numbers that were greater than or equal to 5 and you just add them all up. But show it. You have to show your work like that. Alright, and then see what you get. You know what? I just realized, well, never mind. Alright, I'm getting 0.8283. Alright, find the probability that fewer than 7 of the households have a landline. Fewer than 7. Okay, so that is the probability that x is less than 7. Fewer than, not less than or equal to, less than 7. This is not optional. You must write that down. Okay, so fewer than 7. Alright, these are all the ones that are fewer than 7. So if I want, I could add up these 7 numbers. Okay? But since I know that all of the numbers add up to 1, if I wanted to find the value of the yellow ones that I just highlighted, wouldn't that be the same as starting from 1 and then taking away the other 3? So if I did 1 minus 0.2162 minus 0.1004 minus 0.0207. Alright, if I took these 3 away, in other words, shouldn't that leave behind all the yellow ones? You know, if I erased these 3 by taking them away? So that would just be a little bit quicker. So, you know, that's what I would do. If you're sitting there and you're like, what are you talking about? Then you just, bless your heart, go ahead and add up the 0, the 1, the 2, the 3, the 4, the 5, and the 6. But if you're like, yeah, of course, yeah, if you take away the remaining 3, that's going to leave the first 6. So, you know, 1 minus these 3, that'll work. Alright, as far as showing your work, you can do this. You know, just to save you from writing down all 7 numbers, if you want to show that you're adding by showing the first 2 and then put ... and then put the last one, I will accept that. Okay, and so go ahead and add them up. Oh yeah, by the way, we already added them up, so in this particular case, it wouldn't make sense to do the subtracting thing I was talking about because excuse me, because we did the cumulative distribution, we already have the sum of all 6 of these numbers. We already did it. It's right here. It's 0.6627. So yeah. Alright, so that's all there is to that. Alright, find the probability that exactly 4 of the 9 households do not have a landline. Alright, this just takes one extra small step to get the not having a landline in there. Look guys, we have success or failure, okay? Either you have a landline or you do not have a landline. But the total is 9. Right? So if I want, if exactly 4 households do not have a landline, then how many households do have a landline? Yeah, out of a total of 9, if 4 don't have a landline, that means 5 do have a landline. Okay, so what you need to do is go ahead and switch this up and say, what's the probability that x equals 5? Okay, you simply did 9 minus 4 just then. Okay, it's either way. So if 4 do not have a landline, that means 5 do have a landline. So this is just a backwards way of asking what's the probability that exactly 5 do have a landline. And you can just pull that right off your chart. So that's 0.2194. Again, show your symbolism. I want to see the probability that x equals 5 here. Okay, now last but not least, we need the mean and the standard deviation. Now, to find the mean, alright, the mean is the sum when you do the each x value times its probability. So it's like xp plus xp plus xp. Alright, and so on until the end. The way they write the formula when they do this, they write the sum of all the xp's. This symbol means the sum. But anyways, that means when I talk about the x times the p, I'm looking at you, x and p. So I'm talking about 0 times 0.0001. That's my x and my p. So 0 times 0.0001. So that's my first xp. And then I'm going to do 1 times its probability. Okay, so I'm doing my x and my p. So 1 times 0.0013. 0.0013 plus. Now I told you once you get the idea there by showing the first 2, you can put dot 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 and then skip to the end. Alright, at the end of the list, our last x value is 9. So I'm going to do 9 times 0.0207. This is my x and this is my p. 0207. Okay, but of course in your calculator you need to actually add all 10 values. Okay, so in your calculator you are really doing it. Okay, you are going you know, not that you really need to do the 0, 1 because you know that's 0, but I'm just going to show it. So 0 times 0.0001. Okay, you got 0 plus plus 1 times 0.0013 plus 2 times 0.0098. Okay, I'm just pulling it right off the chart here. Enter. Plus 3 times 0.0424 plus 4 times 0.1181 plus 5 times 0.2194. Enter. Plus 6 times 0.2716. Plus 7 times 0.2162. Plus 8 times 0.1004 plus 9 times 0.02, whoops, I missed the 0, 0.0207. Okay, so I got 5.85. That is the mean. Okay, so 5.85. Alright, that is how you calculate the mean. So keep that in the back of your mind, that the mean is 5.85. Alright, because we need the mean in order to find the standard deviation. I guess I'll just write it down right here. So the mean is 5.85. Okay, now we don't calculate the standard deviation directly. We start with something called the variance, which is just the standard deviation squared. Now the formula for that is it is another sum, but what we do is we do every x value minus the mean that we just found, and then we square that and we multiply by each probability. Okay, so I think I'll just do that down below. So that means, so we're going to do each x value. So that's the 0, the 1, the 9. So we'll start by doing 0 minus the mean. So that's 0 minus 5.85 squared. And then times the same probability like we were doing before. So times 0.0001. Okay, now we're on to this term. So again, we're doing x minus the mean. So we're doing 1 minus 5.85. Alright, that's the x value, which is 1 minus the mean. And then we're squaring that and then times the probability, which is still right there. That's 0.0013. And then you're allowed to do plus, dot, 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 plus, and skip to the last one. Okay, so the last one, again, we're doing x minus the mean. 9 is the x, so 9 minus 5.85 squared. And then times the probability, which is 0.0207. Okay, so we need to do, and that's how you show it without having to write down every term. But in your calculator, of course, you really have to add each one of these. I'm going to show a few of them and do the rest off camera because it's tedious. Okay, so you would do this. Let me clear this out. So, slide this over here. So you would do open parentheses 0 minus 5.85 squared times 0.0001. Okay, so we have that. And then plus. Alright, and then 1 minus 5.85 squared times 0.0013. Well, I think I missed a number there, but you get the idea. And then I would just hit plus, and I would do that over and over again until I got to the end of the list. Alright, I'm going to do that off camera and tell you the answer. But let me pause for a moment just in case anyone's interested. I want to show you how you can use the list functions on your calculator to save you some of this work. So if you're up for it, check this out. Now we already showed you how you would type all of your x values into list 1 if you wanted to generate these probabilities automatically. Now if you want to use the list functions on your calculator to find your mean and your standard deviation, what you need to do is put your probabilities in list 2. So for example, I'm just going to start copying these down. So at 0 we've got 0.0001 and then 0.0013 and then 0.0098, and just type in all of these probabilities into list 2. I've been typing them in, and the last one is 0.0207, so 0.0207. Okay, so remember, I have my x's in list 1 and my p's, my probabilities, in list 2. So for this procedure, I will use list 3 to get all my answers. So we want our formula in list 3. So hit data, switch over to formula, and hit enter. Now, if we're going to do the mean, all right, we did it before by hand. This would be a good way to check our answer. We saw that the mean is the sum of all the xp's, x times p. So using the list function of your calculator, we know the x's are in list 1 and the p's are in list 2. So if I want to do x times p, then I'm just going to do list 1 times list 2. So data and choose list 1, and then data and choose list 2. So I have list 1, list 2. If I hit enter right now, then what the calculator is doing is in list 3 here, it's doing xp, xp, xp. So these are all my xp's, my 0.0013. These are all xp's. Now I want the sum of all these xp's. So what I need to do is I need to hit second data to get to the statistics menu. So if I hit second data, I want one variable statistics, and you have to get your way over to list 3 and just hit enter a few times. Now there's only one of these numbers I'm interested in, and that is item number 5. This is the sum of the entire list. So see that 5.85? That's the same 5.85 that we got by doing this by hand. Alright, but this is a lot quicker. Alright, now in the same way, we can use the list features to find the variance, alright, which is the standard deviation squared. So back in the calculator, I know that the variance is following this formula. So all I'm going to do is change the list formula that's in list 3. So get back in list 3, hit data, go over to formula, add edit, is what you want. So we still have the formula, the x times p formula. Clear that out. This time we want to put in this formula. Okay, so we're going to do the x's, which are in list 1. So we do data list 1 minus the mean, all right, which was 5.85. All right, so x minus the mean squared, and then times the probability. All right, well, the probabilities are in list 2. So I will hit data list 2. Alright, now if I hit enter now, it's giving me all of these terms. Alright, the first number is this, the second number is this, and so on and so on. So I need to add all of these together. So again, all I really need to do is add up every term of list 3. So to do that, I will hit second data and choose one variable statistics and make sure that list 3 is highlighted. Hit enter a few times. Okay, and again look down for item number 5. That is the sum. So I've got 2.0479. Okay, so I've got the variance, okay, is 2.0479. Okay, so this is not the answer. I'm not going to put 2.0479 here. This is the variance. This is the standard deviation squared. If I want the standard deviation, I need to take the square root of both sides. Okay, so if I take the square root, Okay, so let me just get to a clear screen. So if I do the square root of 2.0479, this is going to give me the standard deviation. So that's 1.43, and here at the end I'll go ahead and round. So 1.43. Okay, and that is it. That is how you do that. Okay, so this was 2.0479. Alright, and that was the last problem on this review. I hope this was helpful, and I will see you on the next video. Please, if you're in my class, I'm going to post a blank version of this review so that you can print it out and redo it a couple of times. Just make sure you can do every problem on this review without looking at your notes. And if you can, you'll be in pretty good shape for the quiz tomorrow.